In this video, I will talk about the proof of the circle theorem. In front of you right now, there's a circle there. Let's talk about what we probably already know about circles. So we know that the area of a circle is pi r squared. Pi r squared. And the perimeter of the circle, which we have a term called circumference, is 2 pi r. And we know that 2 times r is the diameter. So diameter is twice the radius. Okay, so this is what we know, but what we're going to talk about is something more complicated than that. So it's called the circle theorem. So let's talk about the first one. So let's call this property 1. Property number 1, number 1 on my list. So what this circle theorem is saying is that the angle at the center is twice the angle at the circumference. At the circumference. Okay. Now, let me take a circle here. Okay. So here's the center of the circle. So here, this is the center of the circle. So I'm going to draw lines here. So let me draw in green. So let me draw it like this. So here, from here, I will extend a line here. So that I will do the same thing. And knowing that these two lines are the radius of this circle. Okay, so I will extend another line here to the other side of the circle. And over here, the same thing. Let's do it like this. So we extend it like this. Okay, so these two lines, they're called the chords. So let me just mention this here. That is called a chord. And this is called the radius. Okay, so now I'm going to erase this because I don't need this. Okay, so let's call this angle here, angle theta, right? This angle here. And let's call this angle here, angle alpha. So it's this angle and this angle. Okay, so what this theorem is saying that the angle at the center is twice the angle at the circumference. So this is the angle at the center, and this is the angle at the circumference because that's the circle right here. So it's a circumference. So what we're trying to prove here is prove that theta is equal to 2 alpha. That's what we're trying to prove. Okay, so let's do this. I'm going to just take this circle and then relabel this. Okay, so this is the exact same thing from there. Okay, let me erase this. And I'm going to relabel this. So I'm going to take away the alpha here. And I'm going to take away the theta here. Because we already know what they are, okay? So that's how we label this. Now, what we have to do is, okay, to prove that, what I would do is I would draw another line here connecting the top here. Notice that this line here is also the radius of this circle because they're all starting from the origin, like these three lines, 1, 2, 3. They start from the origin basically, well, they start from the center of the circle. That's what I should say. Okay, they start from the center of the circle and extend to the circumference. So it's the radius of the circle. Okay, so at this point, I will keep this as angle theta. Okay, over here, I will relabel all the angles here. Now, know that this line and this line, they should be equal because they both are the radius of the circle. What that means is that this triangle here should be an isosceles triangle. So what I can say is that this angle here and this angle here should be the same. So let me call this angle A, then this also angle A. So similar to this situation here, this is also an isosceles triangle because this side and this side are the radius of a circle, so they are equal. They have equal length. Then the angle here and the angle here should be the same. So I will call this angle B. Angle B. Okay, so what can you say from here? Now let's look at this angle here. Well, A and B. A and B together is alpha because I just take the original diagram and just move it here and then relabel things. So we can say that, okay, over here, A plus B is equal to alpha. Okay. So, and this angle here and this angle here, they will be different from the other two angles. So, let me call this angle C. Let me call this side angle D. Well, let's say it that way. Okay. So what I want to say is that, okay, the reason why I label this angle A, C, and this side is B, B, D, because then they don't necessarily need to be the same angle. So this triangle is not necessarily the same size as this triangle because the point of connection here could be here, could be here, could be here, could be here. It's the same thing. I mean, the angle A plus B will still be the same if we do it like that. So, but these two angles may not be the same. But that's why I'm trying to do it that way. And I can still prove to you that alpha is equal, theta is equal to 2 alpha. Okay, let's begin. Okay, what we know is that all three angles in a triangle should add up to 180 degrees. So 3 angle here, for example, A plus C should be equal to 180 degrees. Let me switch back to yellow. Okay, so 2A plus C is equal to 180 degrees. So this is for the first triangle here. Now let's look at the second triangle. Right? B plus D should be also equal to 180 degrees. So 2B plus D is equal to 180 degrees. Okay, so what else do we know? Okay, let's look at this angle here. So this angle here. So the full angle here is 360 degrees. So C plus D plus alpha. Okay, C plus D plus theta should be equal to 360 degrees. So C plus D plus theta is equal to 360 degrees. Okay, so let's just to show you that, okay, here. Okay, so let's add these two equations up here. So 2A plus 2B is 2A plus 2B plus C plus D plus C plus D equals, okay, this side, 180 plus 180 is 360. Okay, now let's use this equation here. C plus D plus theta equal to 360. But in this case, okay, so this one is a plus. So this time I will subtract this equation. So 2A plus 2B minus nothing here. So it will still be 2A plus 2B because it's subtracting 0. But C plus D minus C plus D is 0. Then 0 minus theta will be minus theta. So 360 minus 360, 0. Okay, from here, what we can do is, let's add theta to both sides. 2A plus 2B is equal to theta. Then we can factor the 2 out as common factor. 2 times A plus B equal to theta. Okay, what is A plus B we said before? A plus B is equal to alpha. Okay, so it's equal to alpha. So we can replace A plus B with alpha. So 2 alpha is equal to theta. Okay, so what we getting here? 2 alpha is equal to theta, which is what we are trying to prove there. Theta is equal to 2 alpha. So we just prove this property here. The angle at the center is twice the angle at the circumference. So the angle theta is twice the angle alpha. So even though the connection point is somewhere, let's say here, right? So that means it could have been connected like this. Here, and then here, something like that. Right? This one is still angle alpha. Or even if the connection point is here, so let's say here, right? This, put it here, and then here, this is still angle alpha. Okay, so this is what it means. Okay, next, let's talk about the second property of the circle theorem. Property number 2. Well, number 2 on my list, I mean. Okay, so property number 2. Property number 2. What it's saying is that the angle in a semicircle is a right angle. Okay, so what that means is that, okay, there's a circle in front of you. Let me draw the center of the circle, which should be around here. That's the center of the circle. And I'm going to draw a line connecting this center of the circle. So we know that this line here is called the diameter of the circle, which is twice the radius here. Okay, so let's talk about this theorem here. So I'm going to switch to green. So I'm going to draw a line here. So a line connecting from the circumference here, let's say another line coming down here. Okay, so what color is similar? Let me use magenta instead. Okay, so I will redraw these two lines here. Okay, as you can see, the two magenta line here, they have not gone through the center of the circle, so they are called the chords in this circle. And the yellow line here is the diameter of the circle. Okay, so what they're saying is that, okay, the angle in a semicircle is a right angle, so basically this angle here should be a right angle. This is what it's saying. So let's call this angle alpha. So what we're trying to do here is prove that, oh, this is angle theta. Okay, so sorry, that's angle theta. I should say angle theta. Okay, let's prove that theta is equal to 90 degrees. That's what we are trying to prove right here. Okay, so how do we do that? So let me just copy this circle here, this diagram. And copy to here. Okay, so this is the exact diagram that I just copied from here. So what I'm going to do now is, let me just take away this part here. We know that this is theta. Okay, so let's do this. Okay, so I'm going to draw another straight line from this point connecting to the center of the circle. Now, realize that when I'm trying to connect this line, right? So from the center of a circle to the circumference of the circle, this one is not a chord. It's actually the radius of the circle here. So what does it mean? Oh, that means that, okay, so let me label it here. This line and this line, they both are the radius of the circle because they all come from the center of the circle. So they should be equal. So that means this triangle here is an isosceles triangle. Has two equal sides. So that means this angle and this angle should be the same. So let's call this angle A and angle here. So because they're supposed to be the same. Okay, let's look at this triangle here. Again, so this side and this side, they are the radius of this circle. So they should have equal length. That means this is also an isosceles triangle. So that means this angle and this angle here should also be the same. And let me call this angle B and angle B. So in this case, I can just call this angle C and angle D here on this side, so doesn't matter. Okay, what we can start by is, okay, all angles, all three angles in a triangle should add up to 180 degrees. So that means A plus C should be 180 degrees. So we can write that here. A plus A is just 2A. 2A plus C is equal to 180 degrees. And also here, right, this is also a triangle. So B plus D should be also equal to 180 degrees. So 2B plus D is also equal to 180 degrees. Okay, what else can we write? Well, we know that this angle here, C plus D, is 180 degrees. So we can write that C plus D is equal to 180 degrees. Okay, so let's try to do something here. Okay, with these two equations, we should add them up. So let's do this. Add them up. Right, 2A plus 2B is 2A plus 2B plus C plus D is equal to, on the right side, 180 plus 180 is 360. Okay, with this, we have another equation here. C plus D is equal to 180 degrees. So this is 180. We can replace that with 180. Okay. Over here, let's subtract 180 from both sides. We have 2A plus 2B is equal to 180. Now the 2 here is common, so we're going to factor the 2 out. So we have 2 times A plus B is equal to 180. Now divide both sides by 2, we have A plus B equal to 90 degrees. Okay, but what is A plus B? Okay, A plus B is this angle here. And from the original diagram, A plus B is angle theta. So it's angle theta. So that means we can say that A plus B is equal to theta. So that means theta is equal to 90 degrees. Okay, so here's the proof. Now, we just proved that angle theta here is 90 degrees. Okay, let's move on to property number 3. Well, again, number 3 on my list. So let's call this property 3, number 3. So what it's saying is that angles in the same segment are equal. Okay, so first of all, what is segment? So let's define segment first. So let me say, okay, so that is the center of the circle. And I have a line going through from this side of the circumference to this side of the circumference. So notice that this line did not go through the center of the circle. So this line here is called the chord. And the segment of the circle is going to be this area here. Okay, so that's the segment of the circle. Okay. Now, let's come to this theorem here. So let's define the segment here for this theorem. So I'm going to use magenta. So let me say from here, this point here, and let's say also say this point here. So the segment will be here. Let me try to color this. I try to fill in the circumference of this circle with this magenta, so that is visible. So you can see that, okay, so this is the segment we're talking about. Okay, so like this. Okay, so that's the segment here in magenta. And what I'm going to do now is draw the lines. So let me go from here, from the end of this segment, let's say to this side here, and then from here to the other side of the segment. Similarly, on this side, the end of the segment, I will have a line going through here and then coming down to the other side of the segment. So this theorem, what this theorem is saying is that this angle and this angle should be the same. Okay, let me just call this angle x, this angle y. So what we have to prove here is prove that angle x is equal to angle y. That's what we have to prove. Okay, so to start doing that, I'm going to copy this diagram again to another area. And let me paste it here. Okay, so I think I need to erase this here. I think there's some marks here. Okay, so it's the same diagram, and I'm going to relabel this. So I will erase this x and y here. Okay, so what I'm going to do now is, let me find, okay, the center of the circle. So that's the center of the circle, and I will connect a line from this segment to this center of the circle, and also same thing here to this side. Knowing that, okay, so these two lines connects the center of the circle to the circumference, and they are called the radius. They are actually the radius. And the blue lines, they are the chords because they don't go through the center of the circle. They're the chords in this circle. So what should I do? Okay, let me call this angle theta. Okay, so this angle here is angle theta. So angle theta. So similar to circle theorem number 1, I'm going to draw a line from here to this point here, and then another line from here to this point here. Okay, so again, so these two lines, they come from the center of the circle to the circumference, so they are the radius as well. So the 4 yellow lines are the radius of the circle, and the 4 blue lines are the chords in this circle. So I would do the same as, I will apply the concept as the circle theorem number 1. So what we notice here is that this and these two lines, so these two lines, they are the radius of this circle. That means they should have equal length. So what does it mean? That means this triangle here, so this triangle here should be isosceles triangle. That means this angle and this angle here should be the same. Okay, so let me define this. Okay, let's say this is angle A. This one here, angle A, and this one here, angle A. Okay, so because they have the same angle. And how about this angle here? Well, this angle here, let's call this angle C. So this is angle C. Okay, so let's look at this triangle here. Okay, this one. Again, this side and this side, they are the radius of this circle, so they should have equal length. That means this triangle here is also an isosceles triangle. So that means this angle and this angle here should be the same. So let's do this. This angle and this angle here should be the same. Let's call this angle B, angle B, angle B. And so this angle here, we can call this angle D. So let's call this angle D. Angle D, so this angle here. Okay, now let's look at this one here. Then to look at this one, let's start with this triangle. So this side and this side, they both are the radius of this circle. So that means they should have equal length. That means this triangle here should also be an isosceles triangle, and this angle here should be the same. Well, let's call this two angle, right? This two angle E. So angle E. And this angle here, well, let me just do it like this. This angle here, let's call this angle F. Okay, so this angle here is angle F. So this angle formed by these two yellow lines. Okay, now let's look at this triangle here. This triangle. Now again, this and this, they both are the radius of the circle. So that means they should have equal length. That means the angle here and the angle here should be equal. So let's call this two angle G. So that's angle G and that's angle G. And how about this angle here? So let's call this angle here angle H. So this small angle here, so this small here and this small angle here is angle C. Okay? And this large angle here is angle D. Okay. Okay, so what can we say here? Okay, what we have to prove is that, okay, the angle A plus B is equal to the angle E plus G. So prove that angle A plus B is equal to angle E plus G. So what we're trying to do here, okay, so we're trying to prove x equal to y here, angle x equal to angle y here, and this is the same diagram. So over here, A plus B is x, E plus G is y. So we can also say that angle A plus B is equal to angle x, angle E plus G is equal to angle y. Okay, let's see what we can do. So applying the concept in the first circle theorem, we have to write something like this. Okay, so we know that, okay, so this angle here is angle C, right? We have A and A, so this is triangle. All three angles inside a triangle will add up to 180 degrees. So we can say that A plus C is equal to 180 degrees. So we can say that, okay, 2A plus C is equal to 180. Okay, now let's look at this triangle here. Okay, so this triangle. So angle B and angle D. So this is angle D. Well, these three angles will add up to 180 degrees. So 2B plus D is 180. So we can say that 2B plus D is equal to 180. So that's plus. Okay, what else can we say? Okay, we know that over here, this is angle theta. And this is C, angle C here, and that whole thing is angle D. So again, this is angle theta. This big angle is angle D, and this small angle is angle C. So them three together, C plus D plus theta, should be equal to 360 degrees. So we can also write that. C plus D plus theta is equal to 360. So this one here. Just to make sure that this is D. Okay, so what happened now is, let me add these two equations up. So add this. So 2A plus 2B is 2A plus 2B. Right, C plus D is C plus D. Equals to the right side, 180 plus 180 is 360. Okay, we have this equation here. Let me subtract this equation. Subtract this. C plus D plus theta is equal to 360. Okay, it's 2A plus 2B minus 0 here is 2A plus 2B. C plus D minus C plus D is 0. 0 minus theta is minus theta. On this side, 360 minus 360 is 0. Okay, so what we have here is, or let's isolate this. Add theta to both sides. 2a plus 2b is equal to theta. Now, the 2 is a common factor, so factor out the 2. So 2 times a plus b is equal to theta. Now, isolate a plus b. Divide both sides by 2. You get theta. You get a plus b equals to theta over 2. So that's theta over 2. Okay, so what we're doing is here, here is, finding what angle a plus b is. So this is angle a plus b. So we can also say that that's just angle a plus b equal to theta over 2. Okay, so let's look at this side here. So this side. Okay, so from here, from this triangle here, we can say that, okay, this is a triangle, right? All three angles add up to 180 degrees. So E plus F should be 180 degrees. So let's say 2E. So we have 2E plus F equal to 180 degrees. Okay, so that's this triangle here. How about this triangle here? Right, so it's G, angle G plus angle H. So 2G plus H is 180 degrees as well. So 2G plus H is equal to 180 degrees. Okay. What can we say here? So we know that this angle here is angle F, this bigger angle here is angle H, and this angle is angle theta. So the sum of these three angles will be 360 degrees. So we can say that H plus F plus theta is equal to 360 degrees. Okay, so let's see what we can do here. Let's add up these two equations. So we add them together. So 2E plus 2G is 2E plus 2G. Now F plus H is plus F plus H. On the right side, 180 plus 180 is 360. Okay, we have this equation here. So I will subtract this equation by this equation here. So minus H plus F plus theta equal to 360. So what I'm doing here is, okay, here, 2F minus, okay, no, this is 2E. Okay, so 2E, so it's 2E here, so 2E. 2E plus 2G. Okay, so 2E plus 2G minus 0 is 2E plus 2G. Now, F plus H minus H plus F, same thing, so it's 0. 0 minus theta is minus theta. Right? On the right side, 360 minus 360 is 0. So what we can do here now is, okay, add theta to both sides. We have 2E plus 2G equals to theta. Factor the 2 out, E plus G, by 2 times E plus G equal to theta. Then divide both sides by 2 to isolate E plus G is equal to theta over 2. And what we are trying to say here is, okay, angle E plus G. So we have this. This is basically angle E plus G is equal to theta over 2. Now let's combine everything we have. Angle A plus B is theta over 2. Angle E plus G is theta over 2. So they both are equal to theta over 2. That means they both are equal. So I can say that angle A plus B is equal to angle E plus G. So I prove this. So what I just did is prove this one here. But we do know that angle A plus B is angle X. Angle E plus G is angle Y, which is coming from the original diagram. That's how we label it. So we can actually say that, okay, so this is, we know that this is angle X, and we know that this is angle Y. So we just prove that angle X is equal to angle Y. Here, that's what we're trying to prove. Angle X is equal to angle Y here. So we just proved that angles in the same segment are equal in a circle. Okay, let's move on to property number 4. Again, number 4 on my list. So what property number 4 saying is that property number 4, opposite angles in a cyclic quadrilateral sum to 180 degrees. So a quadrilateral is a diagram that has 4 sides. So let me draw this. There's a circle here, and I'm going to draw a quadrilateral inside a circle touching the circumference. So this is not really necessarily a rectangle, but it's a quadrilateral because it has 4 sides here. And let me define the center of the circle here. So the center of the circle. Okay, so what they are saying is that, okay, so let me have a label here. This angle here and this angle here are they add up to 180 degrees. So this angle plus this angle, so they're opposite angle here, that they add up to 180 degrees. Similarly, on this side, this angle and this angle here, these two angles also add up to 180 degrees because they're opposite angles. So the green and the green add up to 180 degrees, the blue and the blue would add up to 180 degrees. And that would still make sense because these two together, right? They are like basically 180 degrees times 2 is 360 degrees. All 4 angles in a quadrilateral, they add up to 360 degrees. Okay, so let's prove this. So to prove this, I'm going to again just copy this triangle, copy this circle. And then paste it here. Okay, so now I'm just going to draw the lines here. So over here, let me just draw the radius. These are the radius because they're going through the center of the circle, hitting the circumference. So let me do this. Okay, so I do that. So I'm going to call this angle A, angle B. And we know that these are the radius of the circle. So these have equal length, these two sides. Then these are isosceles triangles. So that means this is also angle A. Okay, same thing here. Same length here on these two sides. So this is isosceles triangle. That's angle B. And let's call this angle C. Right? So isosceles triangle again, right? Same length as the radius. So angle C. So again, same length as the radius of the circle. So that this is isosceles triangle. Let's call this angle D. This side is also angle D. Okay, so I have labeled this. So what can I do with this? Well, we know that, right? All these 4 angles add up to 360 degrees inside quadrilateral. So we can always say that, okay, this one, A plus B, right? This one's A plus C, A plus B, plus B plus C on this side. So B plus C, plus this one is D plus C plus D, C plus D, plus this side is A plus D, A plus D, is equal to 360 degrees. Okay, so based on this expression here, we know that each of these letters appear twice. So we can actually write this as 2A plus 2B plus 2C plus 2D is equal to 360 degrees. And 2 is the common factor, so we can factor the 2 out. So we have 2 times A plus B plus C plus D is equal to 360 degrees. Divide both sides by 2. We have A plus B plus C plus D is equal to 180 degrees. Okay, from here, what we can say is, okay, let me separate these 2 angles. So A plus B is one angle, plus C plus D is another angle, is equal to 180 degrees. So this is a bracket, C plus C. So that is one angle, that's another angle. Okay, let's look. What's A plus B? A plus B is here. And what is C plus D? Well, C plus D is here. So that means we're talking about these two angles. They are the opposite angle to each other here. And they add up to 180 degrees here. So that means, and we cannot, I mean, it is also obvious that B plus C, this angle, and A plus D, this angle, they also add up to 180 degrees. So since that's opposite, so we can say that, okay, over here, what we're trying to prove here is, let's say this is angle theta, and this is angle alpha, right? So we know that theta plus alpha is 180 degrees. That's what we just proved for this theorem. Okay, let's talk about another circle theorem, property number 5, or number 5 on my list. But before I talk about this, let me show you one thing. So it has a circle in front of you, and let's say that's the center of the circle. And okay, so let me draw a line here. So it has a line tangent to the circle, tangent to the circumference of a circle. So that's a tangent line, and obviously that's a radius of the circle. If I draw a line down here like this. Okay, so what is special about this? Now, the radius, right, from the center of the circle, right, is from the center of the circle down is perpendicular to the tangent line to the circle. So that means this angle here is always 90 degrees. Okay. Now, so after I tell you this, I will start talking about the property number 5. So let's call property number 5 team number 5. And this is called the alternate segment theorem. The alternate segment theorem. So what is the alternate segment theorem? What it's saying is that the angle between the chord and the tangent is equal to the angle in the alternate segment. So first of all, let me draw something first. So let's say, okay, here, that's the center of the circle. And I'm going to draw a line here. So let me use magenta. So I will draw basically a chord, another chord, and then another chord, because they don't go through the center of the circle. Okay, so now there's a line tangent to the circle. Okay, so that's the line tangent to the circle. So what we are trying to say here is this angle and this angle here should be the same. So let's call this angle y and this is angle x. So this angle, so from here until the tangent line should be the same. Angle y and angle x should be the same. So let's prove this here. Prove that angle x is equal to angle y. That's what we have to prove. That's what the alternate segment theorem is saying. Okay, so how do we prove that? So again, what I'm going to do now is here. Draw a line from the center of the circle to the circumference. And also another line from here to the circumference. As you know, these two lines in yellow goes through the center of the circle. So they are the radius of the circle. Now, what we know now is these two lines have equal length because they both are radius of the circle. So that means they both are the radii of the circle. So that means this triangle here is a isosceles triangle. So that means this angle and this angle here should be the same. And let's call this angle A. And this one here is also angle A. So it's this angle and this angle. And the next thing we have to do is, let's break this out. So by drawing another line here. So this is perpendicular to this chord. So this is a 90-degree angle. I will call this angle B. We call this angle B. Okay. What we have to do now is come up with some equation and then also do the same process as what we have done to prove the other theorem. And from here, we have to actually apply circle theorem number 1 again, because we have this shape. So basically we know that 2b, so 2 of this b, so basically 2b should be twice of y. So I guess b and y should be equal. Okay, so we already see that in from the first theorem. But what can we write from here? Well, we know that each of this triangle, right, a plus b plus 90 degrees is equal to 180 degrees, because all 3 angles in a triangle should add up to 180 degrees. So a plus b plus 90 degrees, well, we know that's right angle, so it's 90 degrees. So let me make sure this is connected. Okay, so that is 180 degrees. So what does it mean? Well, if we subtract 90 degree from both sides, if we subtract 90 degrees from both sides, we have a plus b equals to 90 degrees. Okay, let me just write it again. A plus b equals to 90 degrees if we subtract 90 from both sides. Okay, now what we have to look at now is what I just talked about right before I draw this diagram, is that this is the radius of the circle extended down, and that is the tangent line to the circle. And this angle here is always 90 degrees because that is perpendicular. This radius is perpendicular to the tangent line. So what does it mean? That means, well, we know that this whole angle here is 180 degrees. And what is this whole angle make up of? It's made up of x plus a plus this 90 degrees. So we can say that x plus a plus 90 degrees is equal to 180 degrees. Then subtract 90 degrees from both sides. We have x plus a is equal to 90 degrees. Okay, just look at these 2 equations here. If we isolate b here and we isolate x here, we have b equals to 90 degrees minus a. And we isolate x here, we have 90 degrees minus a. So they both are equal to 90 degrees minus a. Then we can say that b is equal to x. Okay. B is equal to x. So that means this angle here, b, is equal to this angle x here. So how is that related to angle y? Again, right, we just talked about the first theorem, the circle theorem. Now, 2b should be twice of y. So we can always say that 2b is equal to 2y because this angle is twice as large as this angle. Well, if 2b is equal to 2y, then I can always just divide both sides by 2. Then I have b equals to y. Okay, so b is equal to x, b is equal to y. So x and y should equal each other. So I will write that angle x is equal to angle y. That's what we're trying to prove here. So we just proved that angle x is equal to angle y, and that's the alternate segment theorem. So here are the proofs of the circle theorems. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.